Very good afternoon, ladies and gentlemen. I'm happy to host episode number 13 of Breaking Bread with DMI. I've got a very special guest today with me who has come all the way from Pune, Dr. Ganesh, Dean MIT Pune. Well, it's good to meet you, sir, in Bangalore after almost I can see 5 years.
Yeah.
Last, Dr. Ganesh regularly contributes in a magazine, Dynamic Manufacturing India. So, to start our conversation, sir, I want you to introduce yourself, what all you do to our readers.
Hello everyone, this is Professor Ganesh Kakandikar and I am presently working as Dean for External Relations at Dr. Vishwanath MIT University, Pune. And we are a very old institution in Pune based in central Kochi, and very famous institution for engineering education, that to value-based engineering education for last 4 decades. Presently, I am working with industry, academia, and research organizations. I do also work with parents and my alumni college. So my job right now is to connect with the stakeholders of my university, wherein I can think of how I can facilitate the development of the students, how I can connect them with the industry, how I can connect back my alumni with my current students so that they can handhold them when they will pass out or prior they pass out and they want to go to market. We do a lot of activities apart from regular academics for the overall development of the students. A lot of co-curricular activities where we have a lot of clubs, so almost 60 plus clubs in the entire School of Engineering and Technology, where students work on very niche products, and I'm very happy to share that we have a club on Hyperloop, which is a magnetic leviation vehicle in vacuum tube basically, and we are in the top 6 teams of the students in the entire globe. And we regularly participate in European Hyperloop Week. Last year also we were in Edinburgh, England. And we are in top 6 teams. We do participate in a lot of Society of Automotive Engineers activities. My team is at the top at national level. And we work on different areas: robotics, unmanned aerial vehicles, coding, hackathons, chem cars, chemical engineering cars, a lot of petroleum projects, oil and gas projects, mechanical engineering is vast. So we give a lot of couple of activities to the students for their overall development.
Dr. Ganesh, mechanical is a very old, I can say, department. And how do you see this department right now doing? One, because since you are one of the main, I can say, dean, and who has seen the journey as an education side, because people want to move to IT and other industry. How do you see mechanical industry going and your college A, and secondly, how do you see overall future for somebody who is looking to be a mechanical engineer?
See, mechanical is a core branch. When we started engineering, there were 3 core branches that we talked about: electrical, mechanical, civil engineering. At the time, those on we evolved certain application-oriented branches like electronics and communication, production engineering, instrumentation engineering, industrial engineering. So mechanical is all about manufacturing. We are the people who think of, who designs, and who creates.
Correct.
So ideas are converted into real products which work for comfort of the people. So my job is to create machines which gives comfort to my customers. And so mechanical is evergreen branch. Recently, if you see the developments that those have happened in engineering and technology, mechanical engineering has also gone through a lot of such changes. There is an entire interdisciplinary approach in engineering because the products become smart. So conventionally, looking towards a car, I was saying that it is entirely a machine, made by a mechanical engineer. Today, I cannot say because it has got maximum 36 sensors, a microprocessor, a lot of instrumentation, a lot of electrical connections. So now a mechanical engineer obviously, has to understand all these branches. So knowledge of computers, knowledge of electronics, communication is required because every product that we design and manufacture is a smart product. Cloud, starting with so domestic products like refrigerators, is a smart refrigerator, air conditioner is a refrigerator. To very sophisticated products like aircraft. isn't it? So, mechanical engineering will evolve. Now there is a boom in IT sector. No doubt, IT has helped us a lot to expedite the manufacturing processes, to keep the data, to take intelligent decisions in manufacturing also. So IT will exist with us, but now children are more fascinated with the stories of Silicon Valley.
Correct.
Now Silicon Valley doesn't exist.
Correct.
Americans are also saying that Americans first.
Yes.
And the reality is that world has become a global village. You can travel anywhere. You can sit at any part of the world and you can do a business.
Yes.
So it's not necessary that you should go and settle down. And today's trend, what I could see, children doesn't understand. They are fascinated with tools mostly like AI, ML, artificial intelligence. But artificial intelligence is a tool, and we need systems wherein the tool can be implemented. The systems are made by only mechanically. Okay, so if the systems are not existing, you cannot use AI. So if you don't have a car, you cannot apply AI, to make the car more comfortable. So children have to understand now that every branch, be chemical, petroleum, petrochemical, to civil engineering, every branch has got the necessity of implementation of such tools. Okay. So no doubt they can get expertise into the tools by learning one core branch. So somebody in mechanical engineering can learn AIML along with his curriculum. He can implement for his purpose. He not to become an IT engineer or a computer engineer and only learn the tools. Okay. So there is a vast scope for everyone to learn and implement AIML.
And what sort of initiative you are taking in your campuses to encourage the onboarding people in different departments? What sort of placement is something which I wanted to come later, but I want to add now that how do you see the company or let's say industry academia collaboration? How do you see that part of the value chain is being taken care of?
See, we, being an university now, we have the freedom to modify the curriculum.
Okay.
With 4 decades of experience, we have my alumni sitting at very designated positions on the globe.
Yes.
And we have stakeholders like industry, we have stakeholders like advisory boards, board of studies, academic council, and we can see what is happening in the market and how the technology will emerge out in coming 2 years, 3 years, that we can add it to curriculum. That is the one way. Once I talked about interdisciplinary approach, now I only do 60% mechanical engineering to mechanical engineering students. 40% what they learn from electronics, electrical, computer. So those things have been taken care that my mechanical engineer is well equipped with whatever knowledge that is required right now to work in the industry. We do a lot of activities to make them, industry ready. We
Yes.
talk about placements. Correct. See, the age right now is of networking, competition, attitude.
Yes.
And I feel knowledge matters slightly less.
Okay.
Because you can gain it whenever it is required. There is a lot of exposure and resources available. Right now, if you have not studied something, you can go back just visit. What matters right now in industry is attitude, change management. You are learning and relearning, and then again learning. This is what, because technology is continuously changing. So we do a lot of those activities for children. We provide them a lot of exposure at national level, international level, and MIT is very famous for value-based education. So we want to make them good human beings, apart from an engineer. He can be a good engineer, but if he is not a good human being, unfortunately, he will take bad decisions. This is what we have been taught of our grandfathers and grandmothers, what is good and what is bad. So at any moment of time when a decision comes, as an engineer, I should be able to take what is good and what is bad for society. If I miss that, I'm a bad engineer, I'm a bad human being also. And as I said, now the entire globe is a village.
Yes.
So when I'm designing something, I'm designing for entire globe. So my decision will challenge for each and everyone in the world. Isn't it? So we do a lot of activities like just emphasis. In first year of engineering, we send the children to rural immersion. A very famous program of my university, wherein children stay for 3 to 4 days in villages, in villagers' homes, eat what they are eating, and participate into their day-to-day life. They visit schools, teach those children, do some activities, and the entire aim of this activity is that my strata, 80% of the strata has never seen, this millennium generation has never seen a village. Okay. And India exists 80% right now also in villages, so we have to think of village development. So we have a lot of challenges. So ultimate aim of this is to make them aware that when you work out your projects, many projects, you have to think of that these are the problems you have to solve, you have to address actually. There is a lot of scope for entrepreneurship also. You can start your own company, which will give solutions to all these problems. Correct. Someone can come with a very intelligent solution, you don't know. Yeah. So today's world is of ideas, innovation and invention. Second year, we provide them a national academic immersion program. We feel that all academic institutions in India are good. They have good professors, good facilities. So we send children for 3 weeks to other institutions to stay, take a course from their professors, stay on their campuses to learn a new pedagogy, new culture of another institution, a good institution, which is coexisting with me. So theoretically, it could be competitive to me, but we feel that my executive president feel that why we always should be competitors, we can be collaborators also. And India is very diverse. So someone coming from Pune, staying in Bangalore for 3 weeks, we can enjoy Bangalore food. Chennai is different. You go to Kanyakumari, it's different. Kerala is different. So that diversity also should be shown to children that India is, and this diversity is basically the strength of the India, isn't it? So, third year, final year students, we send them to international exposures to foreign universities for short trips like 1 week, 1 month, or even a semester abroad program. We sponsor them for visiting a lot of expos which are happening throughout the globe, technology expos, Dubai expo. In India also we give them a lot of exposure. And what I talked about clubs, wherein these students work very professionally to take competitions, part into these competitions, because they are almost, the juries are from industry. So things are tested on real life solution situations, and student manufacture, design those things to that level. So this entire profile gives them resume which is industry.
So, Dr. Ganesh, how do you see, we are in 2024, how do you see the top trends according to you will happen, is happening in 2024? The top trends, top 5 trends which you see as a, from the education side, this is the 5 trends in manufacturing 2024.
See, the manufacturing is a versatile activity, and we change on, we moving on with advancements in the technology. Okay, so what I feel in manufacturing will more concentrate in coming days. One is additive manufacturing, which will take a prime role in manufacturing because their creativity and complexity are achievable. We are working with micro scale, nano scale, high speed machining. That will also help us to grow. And the application areas, what I feel, which wherein manufacturing will play a very greater role is the one is the manufacturing of robots, design of robots, and the another is the application of robots in biomedical, healthcare sector, because the next 10 years will be for healthcare sector. And my manufacturing will be more inclined towards healthcare sector. Mechanical engineering entire will be more interested and inclined towards healthcare sector, because healthcare sector will emerge as one of the prominent application area for mechanical engineering. Robotics. Similarly, defense sector will also emerge for us. So unmanned aerial vehicles, application of again robotics. UAE is again a part of robotics. That will also play a greater role because these technologies will keep on changing. What we have never experienced is database management. Extensive database management and manufacturing. So coming days would be of big data in manufacturing, which will help us to take clever decisions. It will help robots. It will help doctors to take intelligent decisions and product life cycle. So I feel next 1 year, 2 year, the things will move around these 4 to 5 concepts. There are a lot of happenings are going on at industry level also and at central government.
I want to take this liberty by asking electric vehicle sustainability, these are the two things which is being talked in every forum these days. How do you see the electric vehicle implementation in India? Now we have started, I see the trend moving in a positive way. How do you see the EV doing in India? B, what sort of courses or what sort of curriculum you have structured in EV battery so that because people say future is EV and India is working on the battery technology. How do you see this industry moving?
See, though we are talking about fossil fuel, we are talking about EV for last 30 years. No doubt, last couple of years, it has got a lot of boom with a lot of facilities and schemes by central government. Personal usage of two-wheelers and four-wheelers definitely have increased. But still, we are struggling with mass transportation, public transport systems, wherein still buses doesn't have that much of capacity which is required. And though few of the cities and few of the state transport corporations, they have started working on it, but we'll have to go along. But what I feel overall, even we convert on EVs, we require a power. Okay? And power generation is again a real challenge in India, and there also we depend on fossil fuel also. Maximum power generation in India is done on coal. Again, so if the petrol diesel we have a challenge, we will also have a challenge for coal, isn't it? Because that's a natural resource. So I feel that this coming 10 years should be a stop-gap arrangement to convert from IC engines. But I feel the future would be somewhere in hydrogen cars, hydrogen vehicles, because a lot of research is going on. So if you see next decade, we'll see a mix of all. Still IC engine will exist, because we will have to depend on certain application areas where IC engine will only work. So there would be a mix of IC engine, there would be a mix of EV, and hydrogen will evolve. Is it?
And Dr. Ganesh, again, let's we want to bring a focus on students and colleges, the engineering. How do you see the future of engineers in India? I don't want to say future. How do you see the overall education system specifically? Because a lot of changes have happened in medical uh, and management. We see a lot of new courses, a lot of changes I've seen in MBA. So how do you see engineering overall as a division or an engineering college or engineer as a profession in future, let's say 20, 30 years?
See, engineering will always have a great future. There are certain cyclic processes, branch-wise, that happens due to economy and due to other factors. Two most important things that has happened after 2020 is one is national education policy, which is very fantastic effect from central government to make the education inclusive for everyone who deserves it by breaking the boundaries of all mental blocks what we had for last 75 years. And the industry is very open because industry in India came to know that unless and until we partnership with academia that happens like in UK, US, and Europe, we cannot survive. So we cannot have our R&D without academia. And initially, the central government was talking about made in India, so they were not bothered about where it has been designed. So they just want to manufacture in India. Now they say make in India, so make in India means designed, developed, imagined and manufactured in India. And if industry has really understood this, the industry is very open right now, and the children will have a greater future. But if you see, last 10 years, a lot of institutions have closed down. This government has given a fair chance to each and everyone to start an institute. But the time has already decided that the survival is of the fittest. Those were not fit for changing times. They could not keep pace with the changes that are happening in social life and technology. In rules and regulations, they have closed down. So, and with new education policy, smaller colleges, either they will have to merge out with other institutions, being converted into universities, because as per NEP after 20 years, we will not have a single college, we will only universities. Universities must be multidisciplinary. with a single campus. Okay. And NEP has given an excellent opportunity for the children to study, which was not available at my time. So, to just take an example, my students, when they study B.Tech mechanical with a specialization of robotics and automation, we teach them robotic vision. There is a subject called as robotic vision. So, vision is all about video and images. So they can go to School of Electronics. They can take a specialized subject on image processing, or digital image processing, or digital signal processing. Now the same digital signal is used by a mechanical engineer to imbibe into a robot, to make him aware of the situation where he's working. The same signals work into our brains. So the same mechanical engineer is analyzing same signal for predicting eclipsing in patients. Okay. So going down in detail. Now, when you study digital image processing, it's all about an image. And if you want to understand image, you should go to School of Photography, take a subject from photography, and study the image in detail. So, see, this interdisciplinary approach was not available during my education time. NEP has facilitated this at a university level, so children can select their own basket what they want to study. So there is nothing, closed compartment wherein you have to study what is made compulsory by the college authorities. It's entirely flexible, and children can become specialized into whatever they want to do. Like, say, for example, someone is interested in unmanned aerial vehicle, and suppose he would like to start his own venture. So he can go to School of Law and study the laws, regulations of unmanned aerial vehicles in India. This was not possible with earlier situation, but now the children have got all these facilities. I think that there will be a greater future for engineering in coming days. See, always there is a competition. The world rules with survival for the fittest. Yes. What I always tell to my children is that if you see Sachin Tendulkar, Dhoni, or Gavaskar, many such good cricket players, why only these become few of selected crushes? Yes. What they were doing, they were playing cricket only. All others were also playing. Yes. Hundreds of people played cricket in India. Why only we like these people? Or why they could make such history? Because they played cricket, but they played slightly different. Isn't it? Isn't it? With discipline. With discipline. So Sachin was slightly different, Dhoni was slightly different, but they were doing cricket only. So now the coming generation will be engineers, but they have to see by birth for what they are made. So accordingly, they should choose the branch, their interests, their capabilities, and then they should do engineering, but slightly different. That will make them, with marketing.
Interesting concept. My key takeaway is, getting out of compartment-based studies and giving them a freedom to choose according to their liking and how they can shape up their career. I like the concept of college is giving them opportunity to diversify their learnings, which they can do once they come to the industry. I know, Dr. Ganesh, that you have to rush because today you are going back to Pune, but I don't want to miss the opportunity. Intex forming is coming, and forming is something metal forming which is very close to my heart also, because my father used to have a company called Genius Engineering Works back in Odisha. We used to do a lot of work for Raukla steel plant. So how do you see the industry changing in terms of sheet metal? Because like I said, metal cutting lot of sheet gears. So how do you see metal forming doing right now? And what all are the new technologies in that segment?
See, metal forming will have also a greater future. Because see, if you see, 40% of the parts are made from surfaces. Yes. If I say in mechanical engineering, in terms of mechanical engineering, 40% of the parts are made from surfaces, and there are only two options: one is sheet metal, one is a plastic. Yes. And now with environmental pollution, we have already started restraining ourselves from plastic manufacturing. Metal sheet, different metals, newer metals coming up, giving us a lot of applications. And major sectors like automotive, shipbuilding, aerospace, aeronautics will have a lot of requirement of engineers who work on forming. Forming gives that ability to manufacture very complex parts, and that with a mass production. Yes. Isn't it? The beauty of the process is that, like in additive manufacturing, also you can do manufacturing of complex parts, but still we are working on speed.
Yes.
But forming is the process wherein you can go with speed,
Yes.
you can go with accuracy, you can go with mass production. So I think all these areas will emerge out, right? And with the miniaturization, forming has covered a lot of applications in the areas like electronic sector, biomedical sector, okay, mechatronic sector, devices, instrumentation, wherein we are working with very thin sheets below 100 microns, isn't it? Manufacturing of components, where the entire dimensions are into 1 or 2 millimeters, not more than that. So that niche which we got as a microforming is also coming like anything, which has got a lot of applications in space, defense, biomedical. So I think farming will always have a share of 40% of manufacturing as it has been worldwide.
Thank you, Dr. Ganesh. And I can only say this is just a tip of the iceberg. We will be, meeting very soon, Bangalore again, or maybe in Pune at his campus. Uh, uh, Thank you, Dr. Ganesh, for giving us time today. And look forward to meet you in Pune and see the campus.
Definitely.
And we will soon be working on something, a series with Dr. Ganesh, where we would love to know, because I see your PhD thesis and all. I see your content, what you put in your social media. It's very helpful for me also, because I need so, because I can quote that you were outside your college, you were talking something about CNC, because basic things, and some concepts which are easy to take as a third party also, the way you explain. I look forward to do that sort of session in future.
Definitely.
And
My open invitation to you to come and visit my campus. And thank you, Dinesh, for this interview. Coffee, this was unplanned, but yes, we could do it after so many. This was a long-awaited meeting for a couple of years. We were in touch. And thank you, Meshmix Media. Because earlier I have been contributing wherever possible. I did it. I hope to see that we collaborate in future also for society and students and industry.
thank you.